Okay, so this is Chapter 10, problem number 5, which says a bottle has a mass of 35 grams when empty and 98.44 grams when filled with water. When filled with another fluid, the mass is 89.22 grams. And the question asks, what is the specific gravity of this other fluid? So let's go ahead and have a picture of the situation. So imagine that you've got some container, and it's a bottle, and it's sitting on a scale, for example, and we're told that when it's empty, it has a mass of 35.00 grams. Empty. And when it's filled with water, then it has a mass of 98.44 grams. That's water. And then with some unknown fluid, which I'll just call X, the mass is 89.22 grams. Now it says that it's actually it's filled, meaning that really this liquid level goes to the top. That's important to realize. That way you know that the amount of fluid, the volume of the fluid, is the same. Of course, that's going to be necessary when we go to figure out what the specific gravity is, which involves density, and density involves mass and volume. Okay, so that's our picture. Conceptually, specific gravity, which is really just about density. It's the ratio of the density of a particular material to the density of water at 4 degrees Celsius. So really what we should talk about is density is what we need. Okay. Equation-wise, density, again, that's the Greek letter rho. That's equal to the mass of the object or the material divided by the volume. And this assumes that the density is uniformly distributed throughout, which is something that we'll always assume to be the case. Okay, so the specific gravity, let's just go ahead and write this down. The specific gravity of X is defined as the density of X, so rho X, divided by the density of water. Okay, and we know the density of water we're supposed to use when we do these calculations is 1.000 times 10 to the 3 kilograms per meter cubed. And we could do that. The problem is we're going to run into, we don't know what the density of X is. All we know is the mass. In fact, all we know is really the mass of the container with the fluid in it and the mass of the container without. So instead, a better thing to do would be to do this clever trick, which is to realize that the density, since it can be written in terms of mass and volume, let's do that. Let's write the density of X. It's the mass of whatever fluid X is divided by the volume of the container, and the same thing with the water. We can do that. Why not? Let's just write mass of the water divided by the volume of the container. So you realize now the fact that the liquid level goes up to the same place tells you that these volumes are actually the same. That's why I've just written them as V. And so they actually cancel from this equation, which means all you're left with is the ratio of the two masses. Okay. This may not have been obvious to go this step right away, but once you realize you're not able to compute what the density of the fluid is directly, you have to be able to do the problem in terms of things you know, and you're given masses. So the whole answer has to be somehow in terms of the masses. All right, so all we need to do is figure out what's the mass of X and the mass of the water. And we've got some numbers, but we're not quite ready to do it because each of these masses includes the mass of the container itself. So what we need to do is get rid of it. So pretty straightforwardly, the mass of X is the mass of the full container, 89.22 grams, minus the mass of the empty container, 35.00 grams, and the same thing with the mass of the water, so 98.44 grams, minus the mass of the container. Already, hopefully, you would have guessed that the mass of the container with the water and with the other fluid, it's greater with the water, less with the other fluid. So that means that the density of the other fluid has to be less than that of water. So its specific gravity had better be a number that's less than 1. So let's just see what these numbers turn out to be. It turns out that if you do mx over m water, again, this is the specific gravity that we're looking for, this turns out to be 0.8547. and go all the way to 4 decimal places because you're given all these numbers to 4 significant digits. And so that should be your final answer.